Okay, so today we're going to be looking at a free response problem that I found. So the problem itself is that there's a battery with EMF E and internal resistance R, and it's connected to a variable resistance R at points X and Y, as shown above on the left. Varying R changes both the current and the terminal voltage Vxy. The quantities I and Vxy are measured for several values of R, and the data are plotted in the graph as shown above on the right. So the first two questions are determine the EMF of the battery and determine the internal resistance R of the battery. And the reason why I say the first two is because we can do those two together. But first, we're going to figure out what algorithm we need to use. And in this case, since we're dealing with a battery, we're going to use the VIR chart. But to solve the part A and B, the graph gives us the voltage and the current, and we can use the equation V of xy equals E minus IR, and we can solve that using a system of equations from the two easiest points on the graph to find the resistance and the EMF at the same time. So we take our point on the graph. One of them is 4, 1 right here, and we take another one which is at 3, 3, and we take that and we plug it into the equation. So for one of them, we're going to plug in 4 for the voltage and 1 for the current, and one of them we're going to plug in 3 for the voltage and 3 for the current. And we're going to have to multiply one equation by -1 in order to cancel out the e's. So we multiply that equation by -1, and we cancel out the e's, which brings this to be 1, since 4 minus 3 would be 1, and 1 plus -1 plus 3 is then 2. So then we figure out the resistance is 1/2. And then we can take that resistance and plug it into one of the beginning equations, which is either this 4 or this one right here. And we go ahead and we plugged it into the 4 one. And so we did 4 equals E minus 1/2. So you add 1/2 and you get E equals 4.5. Now, so that's the answer for A and B. We figured out the EMF and the internal resistance. The next one is we have to determine the value of the resistance R that will produce a current of 3 amps. So in order to do that, we want to find the resistance when the current equals 3. And the graph already gives us a point, or it gives us the voltage at any given current. And so we can grab the point on the graph to find the current when the current equals 3, and then find the voltage. So we plug that into VIR and solve for R. So R equals V over I. In this case, V is 3 when I is 3. So we get 3 over 3, and R equals 1. So letter D, determine the maximum current that the battery can produce. So we're solving for the maximum current, which always occurs at R equals 0 and V equals 0, at R equals 0 and V equals 0, which we were able to use the graph to find the equation of the line in order to find the x-intercept of the graph. So when V is equal to 0, this is going to be equal to something. So we do the y2 minus y1 over x2 minus x1 to find the slope of the line. We get 4 minus 3 over 1 minus 3, which is 1 over -2, or -1/2 is the slope. We plug that into y equals mx plus b to solve for b. So we plug in with the numbers 4 and 1 again. So we get 4 equals -1, or -1/2 times 1 plus b. And from that, we were able to figure out that you add 1/2 and you get b equals 4.5. So once we get to that point, we solve for x when y equals 0 in the equation. So we get 0 equals -1/2 x plus 4.5. 4.5 equals -1/2 x. And then so we multiply by 2 to get -9, but there's no negative current, so the I max is equal to 9 amps. And then letter E, the current and voltage measurements were made with an ammeter and a voltmeter. On the diagram below, show a proper circuit for performing these measurements. Use this to represent ammeter and this to represent voltmeter. So for this one, we need an ammeter and a voltmeter, and we know that to solve for the maximum current, which is what the ammeter will do, it needs to be in series in order for the full current to be there. So we put the ammeter right here in series with the battery. And in order to find the voltage with the voltmeter, we need it to be in parallel so that it can find the full voltage. So that's where we put the voltmeter. And that's it.